Okay, so how is everyone today?
Great.
Great?
Amazing.
Amazing. Good.
Late math.
Great. All right. So today's the 10th. And last time we had, we talked about intervals and we talked about natural domain. So can someone in plain language remind us what natural domain is? Sorry? Well, not exactly. So in some cases it could be all reals, but specifically the natural domain. The thing you have to ask is you ask about the natural domain of an expression. Okay, so sometimes it can be all reals. Let's have an example. How about something like consider the expression x minus 8 divided by x squared minus 10x minus 24. Okay, so then I could, concerning this, I could ask, find the natural domain. Okay, so what does that mean? So it means find the set of all x's that you can plug in. Because maybe it's the case that in fact it's not permitted that you should plug in some x's. Okay, so just by way of just question to bring you back into the idea, is x equal to 1 in the natural domain? Is that one of the numbers that's allowed? Okay, how do you confirm or deny? Yeah, let's plug it in and just see if it's okay. So in the numerator that'd be 1 minus 8. In the denominator that'd be 1 minus 10 minus 24, which would be what, negative 7. And then this would be 1 minus 34, so that'd be negative 33. So is that a number? Yeah, it is. So so that means that it's fine to plug in 1. Okay, so can you plug in any number whatsoever? Probably not, right? Okay, so then because we've got a division here, what's the one number it's not permitted that you can divide by? 0. So does that mean we're not allowed to plug in x is 0? Right. So x equal to 0 is in fact fine, because that'd be 8 over 24. There's nothing wrong with that. But all right. So how do we figure out when the denominator is 0 then? Yeah, we need to factor it. Okay. So then the main idea here on this exercise is that you cannot divide by 0. Therefore, what we're going to do is we're going to factor. All right. So the numerator is already factored. Can you think of two numbers whose product is negative 24 and whose sum is negative 10? Okay, good. So then x minus 12 multiplied by x plus 2. Okay, so now that we've performed this factorization, I hope it's clear some numbers are not permitted. What's an example of a number that cannot be part of the natural domain? 12, right? Because that particular factor, if you substitute x is 12, then that factor is 0, which means the whole denominator is 0, which would indicate a division by 0, which is not defined. Okay, besides 12, what's not permitted? Negative 2. Okay, So we can say, therefore, the natural domain is x can't be 12, and it is also the case that x can't be negative 2. So if we wanted to draw this condition as a plot, then how would we draw it? Okay, good. So I'm gonna do something here, and I'd like for someone to comment. Well, you said open circle at 12, open circle at negative 2, and I did that. All right. So yeah, the increasing direction is to the right. So the 12 needs to be, 12 is more than negative 2, so it's got to be to the right. I just point this out because this is a very common kind of error that I see. Good. And then if we wanted to write this in interval notation, how do you write it? Negative infinity to negative 2. Union. Negative 2 to 12. Union. 12 to infinity. So we talked about unions of intervals last time, and on some of them, when we wrote unions, it was possible to simplify it. Like the union of two intervals can be simplified into a single interval. Is that the case here? Can you simplify these unions? Why not? Why do these not simplify? Alternatively, what would it look like in the case that that would mean that they would simplify? They'd overlap, right? Do you observe in this thing right here that there are three pieces? There's that piece, the piece in the middle, and the piece on the right, and none of those three pieces have any overlap. So the interval is showing 1, 2, 3 pieces, the plot. And the interval notation is reflecting that 1, 2, 3 pieces, and it's not. There's no simplification that can occur. Any question about it? All right. So here's another one. So how about w minus 3, and then divided by w squared minus 8w plus 15. So in fact, there's two requests. So the first request is to find the natural domain, and the second request is to simplify by cancellation. Wait, 14? Is that what I wanted?
You said 15 and wrote 14.
Okay, yeah, good. 15 is better. I'm not sure what happened there. So I'm going to give you a moment to think about it. Okay, so now I'm going to do just a modicum of work here, just a little bit. So just like just like the previous one, it's a good idea to factor. So first I'll factor. So the factorization, the numerator is already good to go, and then the denominator. How does it factor? Very good. Okay, so then I'll leave that there for a second. All right, so then I'm going to answer question number 2 first. Because, well, in my experience, that's the one that students like want to do. It factors like this, just copying that thing up there. Question number 2 says simplify by cancellation. So is there any possible cancellation? Yes. The w minus 3's cancel, right? Okay, so they cancel, and so here's the denominator should be w minus 5, and then because of the cancellation, the numerator should be 0? 1? No, wait, but think something like if you do 5 minus 5, that's 0, right? So this one is not like, let's not use 5. This is not like 8 minus 8. This is like 8 over 8, right? If it were subtraction, you'd use 0 because 0 is what? I'm fishing for a fancy word. That one. The additive identity. Yeah. Because this is like 8 over 8, we don't want the additive identity. That one. We want the multiplicative identity. Which is 1. Okay, so that's the answer to part 2. Now, what's the answer to part 1 then? Okay, w is not 5. So is that the answer? W can't be 3? Okay. Well, so the room is split currently. The room seems to be, there seems to be a group of folks who says that's the answer, just that W can't be 5. And a group of folks that says, well, I don't think it can be 3 either. So which is which? What's the answer? Okay, so I want to point something out. When the question was stated, that's the question, right? That one. So we're asking about find the natural domain of what? Of that. Of that, right? Can you plug 3 into this? You cannot. So w minus 3, that's 0 in the numerator. There's nothing wrong with that. 0 in the numerator is fine. As for the denominator, that'd be what? 9 minus 24 is negative 15, plus 15 is 0. So can you plug 3 into the is it permitted that you should plug 3 into this? No, it's not. So in fact, 3 is not part of the natural domain. So if you were to draw this as a plot, it would look like this. And then if you were to write it, in interval notation, negative infinity to 3, union 3 to 5, union 5 to infinity. All right, so I want to make something clear, and that is the cancellation from here to here. If as a completely separate question, if I was to give you a completely separate exercise and ask, find the natural domain of 1 over w minus 5, if just as a completely separate exercise, can this one be evaluated at 3?
No.
Yeah. Yeah, because it's a separate issue. But that's not what was asked. So the reason why I'm pointing this out is because so repetitiously is that what I find is that students do this cancellation thing and then have a difficult time comprehending that I'm asking about the natural domain of the original thing, not this thing that you came to after cancellation. Okay, so then the effect of cancellation from here to here is in some sense like filling in that hole. It like bubbles in that 3 there. Everybody see it? Okay. Any questions before we go to the next thing? Yes?
I guess I'm just wondering why you would ask to simplify by cancellation if it's not going to make a difference in what we put on the number line.
Well, 2 reasons. One reason is that it's an important skill to be able to perform that simplification because it tests can you identify which factors which would cancel, and all of that. And it is also an important test for you to be able, to check your understanding that I'm asking about the natural domain of that, not that. In the end, that's the reason. Other questions? Okay. So, next, how about one like this? So, find the natural domain of the square root of 3z plus 8, and then divide by z squared. Let me think about it for a second. Z squared plus 5z minus 24. All right. So now there's as opposed to the previous examples, the previous examples only offered one kind of problem, and that's a division by 0, right? You can't do that. You still can't do it. But this exercise offers yet another problem. What else could conceivably go wrong? Besides a division by 0. The what? Okay. I think you're definitely on the right track, but you didn't say quite the right thing. Okay, the radicand, which is to say the thing going in the thing, right? This 3z plus 8, the thing that you're putting into the radical, which is properly called the radicand, cannot be negative, right? And it is still the case that the denominator cannot be 0. So you see that there's, in fact, 2 different requirements. Okay? So we have to address them separately. So which one do you want to do first, the numerator or the denominator? Doesn't matter. Numerator? So how do we express the requirement that the numerator has? How do we write it down? So that thing, whatever it is I'm covering up, what must be true? Must be greater or equal to 0. So we'll write 3z plus 8 greater or equal 0. Okay, and then from here, what we must do is, well, let's solve for z. So how do we do that? Good. So 3z greater or equal to negative 8. Divide by 3. Okay, and then it might help us a little bit to be able to express that as a decimal, so I'll do that. How many times can you take 3 away from 8? Twice. So that means that z would be greater than or equal to -2. And then when you take away those 2 3s, how many are left over? 2. And how do you write 2/3 as a decimal? Right, 0.6 repeating like that. Good. So that's -2.6 like that. So that's what the numerator requires. So it's this is saying it'd be fine to plug in 10. It'd be fine to plug in -1. It'd even be fine to plug in -2.5. But -3 would be too much. Can't do it. You can see that right here. If z is -3, that'd be -9 plus 8, which would be -1. Square root of -1, that's not a thing yet. Whatever that means. Okay, good. As for the denominator, what's required? Right. So how does the denominator factor? Very good. So that'd be, it factors as, yes, as you say, z plus 8 multiplied by z minus 3. Okay, and then what does that tell us? Right, because that's the factorization of the denominator. It's not permitted that either factor should be 0. So we can't have -8. We can't have +3. Okay, so then the combined expression, combined. So there's 2 requirements which must be met. So on the one hand, there's z has to be greater or equal to -2 point repeating 6. So there's that one. The other requirement is this, is that z is not -8, z is not 3. And so concerning these, how are we supposed to combine them? Which is to say that I'm fishing for a word that I'm supposed to write right there. And? Or? Which one is it? Should it be and or should it be or? Well, let's think about it. Let's think about it here for a second. This one right here is saying that 3 is not allowed. Is 3 allowed according to that one? Yeah, according to that one it is. So can we plug in 3 here? What would happen if we plugged in 3 here into the whole thing? That'd be 3 times 3 is 9, plus 8 is 17. Square root of 17, that's a thing. That's fine. But it would cause a division by 0 because of the denominator. So it's not okay to do 3. It's and, right? It's and. Because here's the thing: is that this one is this one is what the numerator requires. Otherwise, it cannot go to the party, right? And this is what the denominator requires. Otherwise, it can't go, right? So you can imagine, like you and your friends, each of you says, "Well, tonight I'd be willing to eat either, Mexican food or Chinese food or whatever," and then you say and then just finally, the only way to meet everyone's requirements is to say and, right? I don't know, maybe that's not a good example. Okay, so it's got to be and. So how do we express this compactly as intervals? How do we calculate? What's the right way to do this? So, well, let's consider z greater than or equal to -2.6 repeating. how can we express this as an interval? What would it look like?
You would plot -2.6.
Mm-hmm. Filled in, because it says or equal. Okay, so I plotted that, and then what do I do? Is it all the stuff that way, or what?
Just to the right.
All the stuff to the right. And that's what that one looks like. And then what would this one look like?
Negative infinity to -8.
Mm-hmm.
8 to 3.
Mm-hmm.
3 to infinity.
Okay, so then we'd need to plot -8. Now, is it to the left or right of that? To the left. So we'd have a, -8 like that. And then 3, well, that'd be over here. So what I'm saying is that the numerator's requirement is in red. So that means that if a point is to be accepted, it must be colored red. The denominator's requirement is in green. That means that if a point is to be acceptable by the denominator, it must be green. So it must be the answer is that we need points that are acceptable to both, acceptable to numerator and denominator. Okay. So then there's an I word and a U word, and which one of them do I need to do here and why? Efficient for a word. Which one? Intersection, right? Intersection, because of and. So then the intersection of these two requirements is what? Okay, good. Very good. Okay, so that means that it's these blue points that that can be used. All right. So then this is the answer drawn as a plot. How could we draw it? How could we write it in interval notation? Mm-hmm. To 3. Uh-huh. Very good. So now, can this union be simplified? Why not? Right, because it's that piece or that piece, and there's no overlap. And so the interval notation reflects that. A piece there, a piece there. And then if you wanted to write this, with inequalities, you could say -2.6 repeating less or equal z less than 3. So that's how you could write that piece. And how could you write that piece? With inequalities. Yeah, you could say z greater than 3. But if you had a mind, you might like that. I like this kind because it's always z between two things, right? That's the left thing and that's the right thing. If you wanted to write this one as an inequality, but with z between two things, how could you write it? Well, those two things right there, right? You could say 3 less than z less than infinity. And then what word do I need to write here? This one? So we wrote and here because in order to be able to do this, both of these conditions need to be true. So we said and. And then in the end, that meant intersection. But right here, look at this. What is this one? That's a union, right? So notice that this piece or that piece, that interval or that interval, this inequality or that inequality, right? So here it's an or. So can someone in plain language explain, well, why is this or even though that one is and? Right. So in order for this to work, we need that to be true and that one. And then you calculate that, and it turns out that when you do that one and that one, the result is that piece or that piece. Any question about this? Yes?
So do you want that to notate the negative 8?
Where? Ah, okay, good. So now, good, I wanted to mention that, is that you might ask, why this question? Why a question of this kind? Okay, so notably concerning the final responses, as a plot, this is the plot answer. This one right here is the interval notation answer, and this one is the inequality answer. And notably, concerning those three, there's no negative 8, right? Yet, negative 8 figured into the middle of the response. So a very common answer wrong answer that is given to this is that somehow student thinks, oh, negative 8's got to be in there somewhere. I've got to do something with it, right? But in fact, negative 8 does not belong as part of these. The reason is because in order to be part of the natural domain, you have to be a red point and a green point. And because negative 8 is so far away from being a red point, it's just not part of it. So that's part of the purpose from a teaching point of view of this exercise. The purpose is to give you that one and see if you're going to bite. What are you going to do with that negative 8? Are you going to recognize that it's not part of it? Other questions?
On the web, like the quiz that we have, will it specify whether they want us to write it in interval or interval?
It'll say all three. It'll say give it like this, like this, like this. Because the point of view, the purpose of doing that is that helps you and me identify if you have a disconnect between the meaning of these three things. Yes?
So would you want us to plot all three, or is it okay if we go straight to the last one, like the?
You mean without doing this?
Yeah.
No, I want to see these,
Okay.
because otherwise it looks too much like magic.
Okay.
Now, later, if you take later math classes, then by all means. But at this level, you're required to do something. In the same kind of way, like I have a daughter, and when she has to add like 27 plus 40 or whatever, then she's supposed to say there's 27, and then supposed to count by tens, 4 of them, like blah, 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 like that. She has to do that, even though she knows. She can do it in her head, but she doesn't get credit. It's the same kind of deal here. So when y'all are professional mathematicians, no one's going to require you to do that. Other questions? Good? Good? Where are we? Good. Let's do this one. So here's a question. I could say combine has a B in it. Combine into a single fraction. And find the natural domain. All right, and the expression is 6 over x squared plus 4x plus 4. And then minus 2 over x squared minus 4. All right. So, to give you an idea of what pardon me, to give you an idea of what's being requested, this is related to the arithmetic problem where you say something like, okay, how about 7 over 15, and then from that we'll subtract, say, 3 over, what do I want? Blah, 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 blah. So 3 and 5, we'll do it like this, 20. Okay. So then, how do you go about doing this? Yeah, best to find a common denominator. Now there is this butterfly thingy where you can say 7. You basically do 7 times 20 and 15 times 3, and then you make the denominator 15 times 20. But this is not a really excellent way to go. It causes a lot of cancellation to occur late, and kind of a problem. Better, I think, is to say that 15 factors as 3 multiply 5, and 20 factors as 4 multiply 5. So now, comparing the denominators, notice that they both have a 5 in the denominator. By way of comparison, this one has a 3, and so that one is in that sense lacking a 3. And this one has a 4, so that one is in that sense lacking a 4. It needs a 4. So what I'm saying is that currently it has 3 times 5, and we'd like for it to have a 4, because if it had a 4, then it would be more nearly similar to that one. But you can't just arbitrarily put a 4 down there, right? What else must you do? Okay, so then now 4 over 4, right? And then by analogy, what's this one missing? It's missing a 3. So I'll put a 3 down there to make it similar to the one on the left. 3 times 4 times 5. Okay, but you can't just arbitrarily put a 3 down there because that changes it. So what else must occur? Must have a 3 on the top. So now that we've done that, notice that the denominators are now the same. This is 3 times 4 times 5, and that one is also 3 times 4 times 5. So that we could say that it is now 28 over 60 minus 9 over 60, which is what, 19 over 60. Any question about this? Okay, so now we want to do exactly the same thing except here. With instead of with integers, we want to do it with polynomials. So that's one of the main themes of this course, is that things that are true for integers are also going to end up being true in a certain sense for polynomials. So just like you can factor an integer, you can factor a polynomial. So how does that one factor? That denominator. Right, it's x plus 2 and then another x plus 2. So this would be 6 over x plus 2 and then multiply by another x plus 2 minus 2. And then how does x squared minus 4 factor? Very good. So like that. So now, well, you can see that this one has one of those and then another one, right? And then by way of comparison, this one just has one, right? Just has one of the x plus 2's. So to make it right, to make it compatible, we need to have another x plus 2 for that one. So writing that, So far I haven't done anything except just rewrote it with longer horizontal bits there. So, but I did just say that, oh yeah, this one needs an x plus 2, so that it will be like that one and have two of them. But you can't just arbitrarily put that there. What else must you do? It must also be in the numerator. All right. Good. And by way of, you know, analogy, what is this one missing? It's missing an x minus 2. So we'll give it 1, so that it is like that one. But in order to make sure that we didn't change the exercise, we also must put x minus 2 up here. So is there any question about what we did? From here, it's just a matter of just collecting like terms. So this one would be 6x minus 12, and then subtract, well, 6x minus 12 over x plus 2, and I'll just write squared like that, and then x minus 2, and then subtract 2x plus 4 over x plus 2 squared times x minus 2. So just like over here in the integer example, where we came to here and said, oh yeah, they're both over 60, so now we can just do it. Notice that they're both over the same thing now. Okay, so I'm going to make an error. 6x minus 12, that numerator, and then minus 2x plus 4. And then all over that same thing. Okay, so hit me with it. What's wrong? Wait, what do you mean? Because just like this one is 20, so both over that, 28. That one minus that one, right? That one minus that one. Ah, right? Because it's this whole numerator minus that whole numerator. Which is to say that to make this right, if I, as it's written, if you know, if I put parentheses these ones right there, that changes nothing, right? But remember, it's that whole thing minus that whole thing. So those parentheses are necessary in order to make it right. So before I put those parentheses right there, we were adding the 4. But now we're subtracting. So as a result, the answer is what? 4x's. And then negative 12, so minus 16, like that. Okay. And then, you know, if you cared to do so, you could factor a 4 out of the numerator and get what? X minus 4 like that. So notice that we haven't answered the question, at least not completely. What remains to be answered? The natural domain. So what is the so the first thing you need to, one of the things you need to ask yourself is that, did we perform any cancellations? We didn't. See, cancellations, those are the tricky bits. What I mean to say is that notice on this exercise a lifetime ago when we did this, the cancellation from here to here, we canceled the w minus 3 over w minus 3. Moving from here to here, if you just keep your eye on the 1 over w minus 5, then you lose track that 3 is not part of the natural domain. So the cancellation is the tricky part. Did we do any such cancellations? We didn't. So it's fine for us to look at any one of these. So which one? You know, how about the last one? So what's the natural domain? Very good. So that's the, if there's two parts, part 1 and part 2, that's the answer to part 1. And then you could say, and the natural domain is x naught negative 2, x naught 2, as a plot looks like this. Again, I want to press it. I guess it can't be pressed too hard. Notice that the interval, the natural domain, consists of 3 separate pieces. 1, 2, 3 pieces. And then the interval notation also reflects that property, that there is that interval, and that interval. And because there's no overlap between any of the 3 pieces, it's not possible to perform any cancellation. Okay? Finally, this is just something I want to mention, since we're not going to have enough time to do it. If we were faced with something like this, and it was the same instructions. So if it were 9x squared minus 16, and then over 3x squared plus 17x minus 28. Did I make a mistake somewhere? So I'll continue. Divide by 3x squared minus 2x minus 8. Then there's a couple things to be said about this exercise. So x squared plus 5x minus 14. In the first place, okay, you're going to have to factor again. But that one's not too bad because it can be factored as the difference of squares. Difference of squares to product of conjugates. So that one's pretty straightforward. That one's straightforward because it's sort of the easy mode kind. But these two are a little bit less straightforward. Why? Because they're not monic. So you got to do that other thing. Finally, because that's a division, okay, eventually you're going to need to change that division to multiplication by reciprocal before you perform any cancellations. So I encourage you to have a look at this one. Yes?
So do we write the domains before you flip it and after you flip it as well, or just?
You have to consider the domain of it as it is written.
Right.
So notably, that means this whole thing, that thing that's between my fingers, it can't be 0.
Yep.
Other questions? Have a nice whatever day. Monday.